right, so today we're going over least squares approximations. Another way to say that is line of best fit, okay? So in statistics, when we have a whole bunch of data points and we want to find a correlation in between all these data points, what we want to do is minimize the distance between any of the points and the line. There's a couple ways to do this. So one method that we're going to try, let's just go ahead and try to form this into some type of matrix, okay? So let's say we had these points right here. So let's say we had the point 0, 0, and then let's go up to this point right here. Okay, so that would be the point 0, 2. Right, now let's go back 2 over there, and then we'll put this guy right here. Right. Now we're going to call that point negative 2, 2. Okay? And then we're going to have another point that, let's say, it goes up even more. Okay? So 3 and 4. So we have a point over here, which is negative 2, 4. Okay. Now you can kind of eyeball this thing and see that it's going to be a diagonal line that's going like that, okay? And so what are we really looking for in this problem, okay? What we're looking for is the equation of a line. Okay. So, all right, now I'm gonna reorder this in a slightly different way. I'm gonna write it like this. Mx plus b, which equals y. Okay? All right, so we have a whole bunch of x and y values inside of this problem. Okay? So to form this into some kind of matrix, we're gonna have m x1 plus b equals y1, m x2 plus b equals y2, and m x3 plus b equals y3, and m x4 plus b equals y4. Sorry, off the screen. Okay, because we have 4 points. So we basically have 4 equations. But we're only looking for the m and the b. Okay? We're already given all the x's and all the y's. So what I'm going to do is I'm going to form this into a matrix. Okay? Matrix is going to have 4 positions. Value is going to be 4 by 2. Okay. All right. Now this guy is going to act upon m and b. Right. Now, when this matrix acts upon m and b, the x values are going to hit the m's, so that would be x1, x2, x3, and x4, and then 1, 1, 1, 1, y1, y2, y3, and y4. Sorry. Okay. So this is the type of matrix that we're going to be dealing with. So what I'm going to do is I'm going to take this guy, and what I'm going to do is I'm basically just going to plug in my x and y values. Okay? I was given 4 x and y values. So to do this, I'm looking at these guys right here. All right? So Okay. Okay. So all of these spots are just going to be ones. 1, 1, 1, 1 on every single problem. Okay. Right. Now let's consider the values that we have inside of this problem. We have the point 0, 0. Let's use that as the first one. Okay. So point 0, 0. Right. Now we're going to pick the point right above it. The order in which you pick these points does not matter. Okay. All right. The next point, let's say, is just 0, 2. All right. And then the next point would be, let's say, negative 2, 2. Right. And the last point would be negative 2 and 4. So the question becomes, how do we solve this system for M and B? I mean, it seems like there wouldn't really be an answer. Well, we have the trick that we've been using. Let's multiply by the transpose. Okay. So, oh, you have to multiply both sides of the problem by the transpose. So, 0, 0, negative 2, negative 2, 1, 1, 1, 1. 0, 0, negative 2, negative 2, 1, 1, 1, 1. And we have M and B. And this is going to equal, if you multiply by the transpose of one side, you got to do it to the other side of the problem as well. So 0, 0, negative 2, negative 2, 1, 1, 1, 1. Now multiplied by my y values. And so that would be 0, 2, 2, and 4. So it close that off. Okay. So when we do this, it's going to turn it into a 2x2 system, and that's going to allow us to then just use our normal methods of solutions to go ahead and find that rate. So 0, 0, negative 2, negative 2. All right, the top vector acting upon that guy right there, that's going to be, what, negative 2 times negative 2 is 4, and then it becomes 4 plus 4. That's going to be 8. Okay. Negative 2 acting upon 1, 1, 1, 1 is just negative 2 plus negative 2. That turns into a negative 4. Okay. 1, 1, 1, 1 acting upon that guy is also going to be a negative 4. And then 1, 1, 1, 1 acting upon 1, 1, 1, 1 would be, well, 1 4 times, which is 4. Okay, so M and B. And so this thing is going to equal just something with 2 rows. So 0, 0, negative 2, negative 2 acting upon that. So that'd be negative 2 times 2, which is a negative 4. And then negative 2 times 4, which is a negative 8. So negative 4 plus negative 8 is negative 12. All right. And then 1, 1, 1, 1 acting upon that guy, it's going to be 2 plus 2 plus 4. So that's going to be 8. Now that we've gone to this part of the problem, we can say, okay, why don't we form this into our augmented matrix, and let's see if we can't get a solution. 8, negative 4, and 4, augmented with negative 12, 8. Okay, so first thing to do is multiply by 1/2, add. Okay, so 8, negative 4, that would turn that into a 0. And then negative 4 times 1/2 is a negative 2, and negative 2 plus 4 will give us just a 2. Okay, if we multiply 12, negative 12 times 1/2, we're going to get negative 6. Negative 6 plus 8 is indeed 2. And this stays as a negative 12. And remember, we want to turn this into the identity matrix. You can do it on this step, or you can do it on the next step. It doesn't really matter, but let's just go ahead. Let's say I'm going to divide this entire row by 2. So I have 8, negative 4, 0, 1, negative 12, and 1. All right? Now, the next step of this problem is to eliminate that 4 right there. So I'm going to take the bottom row, and I'm going to multiply it by 4 and add it up. That'd be 8, 0, 0, 1, augment 1. Okay, so if I multiply that component by 4 and add it upward, I'd get a negative 8. Okay? So, give me a page. So, all right, so now we're sitting at 8, 0, 0, 1, augment 1, negative 8. And now we're going to divide by 8. And we're going to get 1, 0, 0, 1, augmented with negative 1 and 1. Okay? Right, now that means that M equals negative 1, and that B is going to equal 1. Right? So, Y is going to equal negative x plus 1. Okay. Now let's look back at our problem and see if this really makes sense. So this is going to have an intercept at 1, and it's going to have a slope of negative 1. So if I look back, okay, so I was looking for an mx plus b, and I found y equals negative x plus 1. And if I plot this line, yeah, that makes sense. That's the line best fit for this problem.